the previous chapters, we have discussed about the various aspects that are present with the raster data model and vector data model. In this chapter, we will be discussing about the attribute data model, types of attribute tables, types of attribute data models, that is tabular data model, hierarchical data model, network data model, relational data model and object oriented data model. Attribute data model. The real world entities are so complex that they should be classified into object classes with some similarity through thematic data modeling in a spatial database. The objects in a spatial database are defined as representation of the real world entities with associated attributes. Generally, geospatial data have three major components such as a position, attribute and time. Attributes are often termed thematic data or the non-spatial data that are linked with spatial data or geometric data. An attribute has a defined characteristics of entity in the real world. GIS involves both spatial data and an attribute data, that is spatial data related to the geometric of the spatial features, and attribute data describes the characteristics of the spatial features. The difference between the spatial and attribute data is well defined with discrete features such as the tigris, that is the line feature. The georelational data model stores spatial data and attribute data separately and links the two by the feature ID. The two data sets are synchronized so that they can be queried, analyzed and displayed in unison. Attribute data are stored in tables. An attribute table is organized by rows and columns. Each row represents a spatial feature. Each column describes the characteristics, and the intersection of a column and row shows the value of a particular characteristics for a particular feature. Arrow is also called a record and a column is also called a field. Types of attribute tables. There are two types of attribute tables. The first type is called the feature attribute table, which has access to the feature geometry. Every vector data set must have a feature attribute table. In the case of the georational data model, the feature attribute table uses the feature ID to link to the feature geometry. In case of the object based data model, the feature attribute table has a field that stores the feature geometries. Feature attribute table also have the default field that summarizes the features geometrics such as the length of the line feature, the area and perimeter of a polygon feature. A feature attribute table may be only table needed if a data set has only several attributes, but this is often not the case. The second type of attribute table is non-spatial, meaning that the table does not have direct access to the feature geometry, but has a field linking the table to the feature attribute table whenever necessary. Tables of non-spatial data may exist as delimited text, DBase files, Excel files, Access file or files managed by database software packages such as Oracle, Informex, Sybase, SQL Server and IBM DB2. One method of defining attribute data is by the data types allowed in a GIS package. The data types used in a GIS includes character strings, integers, real time numbers, dates and time interval, as in the case of computer programming. Here, each field in an attribute table is defined with a data type, which applies to the domain of the field. The second method for defining attribute data is defining the attribute data by a measurement scale. By a measurement scale, attribute can be categorized as nominal, ordinal, interval and ratio. Nominate data describes different kinds of different categories of data such as land use, types or soil types. Ordinal data. Ordinal data differentiate data by ranking relationship. For example, cities are classified as big cities, medium cities and small cities according to the population. Interval data. Interval data describes intervals between values such as temperature and pressure reading. For example, the temperature reading of 60 degrees Celsius is hotter than a temperature reading of 40 degrees Celsius. Ratio data. The ratio data are the same as interval data except that the ratio data are based on meaningful or absolute zero values. Population density is an example for ratio data, where a density of 0 is an absolute 0. The above four measurement scales can be grouped into two higher level categories such as categorically, which includes nominal and ordinal scale, and numerical, which includes interval and ratio scales. Types of attribute data models. A separate data model is used to store and maintain attribute data for GIS. These data models may exist internally within the GIS software or may be reflected in external commercial database management software. A variety of different data models exist for storage and management of attribute data. The most common models are tabular model, hierarchical model, network model, relational model and object oriented model. The tabular model is a manner in which most early GIS software packages store their attribute data. The next three models are those most commonly implemented in database management system. The object oriented model is newer, but rapidly gaining in popularity for some application. A brief review of each model is provided. Tabular model. The simple tabular model stores attribute data as sequential data files with fixed format or delimited for ASCII data for the location of attribute values in a predefined record structure. This type of a data model is outdated in the GIS arena. It lacks any methods of checking data integrity as well as being inefficient with respect to data storage. This type of data model is just used for data entry structures. Hierarchical model. The hierarchical database organizes data in a tree structure. Data is structured downward in a hierarchy of tables. Any level in the hierarchy can have unlimited children, but any child can have only one parent. Hierarchical DBMS have not gained any noticeable acceptance for the use within GIS. They are oriented for data sets that are very stable, where primary relationship among the data change infrequently or never at all. Also, the limitation on the number of parents that an element may have is not always conducive to actual geographic phenomena. Several records or files are hierarchically related with each other. For example, an organization has several departments, each of which has attributes such as the name of director, the number of staff, annual products, etc. Each department has several divisions with attributes of name of manager, name of staff, annual products, etc. And each division has several sections with attributes such as name of the head, number of staff, number of products, etc. A hierarchical model is a tree structure as shown in the figure. A sets a links connects all record types in a tree structure. The advantages of a hierarchical model are the high speed of access to large data sets and ease of updating. However, the disadvantages is that the linkages are only possible vertically, but not horizontally or diagonally, which means there is no relation between different trees at same level unless they share the same parent. Network model. The network database organizes data in a network. Network DBMS have not found much more acceptance in GIS than the hierarchical DBMS. They have the same flexibility limitation as hierarchical database. However, the more powerful structure for representing data relationship allows a more realistic modeling of geographic phenomena. However, network database tend to become overly complex easily. In this regard, it is easy to lose control and understanding of the relationships between the elements. You can see the difference between the hierarchical model and the network model, where in the hierarchical model each of the class, that is nothing but A, B and C, they are present in the same level, but all these values do not have the same parent. Whereas, when we have the network model is being seen, where you can find the linkage or there is a network is being observed from level 3 to level 2, whereas A is having a linkage with 1 and 2, whereas B is having the linkage with 2 and 3, whereas C is having linkage with 2 and 3. So, this way it has large amount of linkages can be found in the network model, or the interlinkages can be found in the layers, but whereas this interlinking of the layers cannot be found in the hierarchical model if they do not share a same parent. Relational model. The relational database organizes data in tables. Each table is identified by a unique table name and is organized by rows and columns. Each column within a table also has a unique name. Columns store the values for specific attribute such as the cover group and tree height. Rows represent one record in the table. In a GIS, each row is usually linked to a separate spatial feature such as forestry strand. Accordingly, each row would be comprised of several columns, each column containing a specific value for that geographic feature. The diagram will present a simple table for forest inventory feature. These tables have 4 rows and 5 columns. The forest strands number would be labeled for the spatial feature as well as the primary key for the database table. This serves as a linkage between the spatial definition and the attribute data for the feature. The table showing the forest inventory feature. Data is often stored in several tables. Tables can be joined or referred to each other by a common column. Usually, the common column is an identification number for selected geographic feature. For example, a forestry strands polygon number. This identification number acts as the primary key for the table. The ability to join tables through use of a common column is essential of the relation model. Such relation models are usually ad hoc in nature and form the basis for querying in a relational GIS product. Unlike the other previously discussed database types, relationships are implicit in the character of the data as opposed to explicit characteristics of the database setup. The relational database model is the most widely accepted for managing the attributes of the geographic data. There are many different designs of DBMS, but in GIS, the relation design has been the most useful. In the relational design, data are stored conceptually as a collection of tables. Common fields in different tables are used to link them together. This surprisingly simple design has been very widely used, primarily because of its flexibility and very wide deployment in application in GIS. In fact, most GIS software provides an internal relational data model as well as support for commercial off-the-shelf, that is COTS relation DBMS. COTS DBMS are referred to as external DBMS. This approach supports both users with small data sets where an internal data model is sufficient and customers with large data set who utilize a DBMS for other corporate data storage requirements. With an external DBMS, the GIS software can simply connect to the database and the user can make the use of the inherent capabilities of the DBMS. The external DBMS tend to have much more extensive querying and data integrity capabilities than the GIS internal relation model. The emergence and the use of the external DBMS are a trend that has resulted in the proliferation of GIS technology into more traditional data processing environments. The relational DBMS is attractive because of simplicity in organization and data modeling, flexibility, data can be manipulated in ad hoc manner by joining tables, efficiency of storage. With a proper design of data tables, redundancy data can be minimized. The non-procedural nature, queries on a relational database do not need to take up into account the internal organization of the data. The relational database management system has emerged as the dominant commercial data management tool in GIS implementation and application. Types of relationships. A relational database may contain 4 types of relationships or cardinalities between tables, or more precisely between records and tables, that is one to one, one to many, many to one and many to many. The one to one relationship means the one and only one record in the table is related to one and only one record in the other table. The one to many relationship means that one record in a table may be related to many records in other table. For example, a street address of an apartment complex may include several households. In a reverse direction form, one to many relationships, the many to one relationship means that many records in a table may be related to one record in another table. For example, several households may share the same street address. The many to many relationship means that many records in the table may be related to many records in another table. For example, a timber strand can grow more than one species and species can grow in more than one strand. To explain these relationships one to many, the designation of the origin and the designation can be helpful. For example, if the process is to join attribute data from a non-spatial data to a feature attribute table, then the feature attribute table is the origin and the other table is the destination. The feature attribute table has a primary key and the other table is the foreign key. Often, the designation of the origin and the designation depends on the storage of data and the information. To take advantage of a relational database, we can link tables in the database for the purpose of data query and management. There are 3 ways of linking tables, that is join, relate and relationship class. Join. A join operation brings together 2 tables by using a common field or a primary key and foreign key. A typical example is to join attribute data from one or more non-spatial data tables to a feature attribute table for data query or analysis. It is usually recommended for one to one or many to one relationship. Given a one to one relationship, 2 tables are joined by record. Given a many to one relationship, many records in the origin have the same value from the record in the destination. A join operation is inappropriate with one to many or many to many relationship because only the first matching record value from the destination is assigned to the record in the origin. Relate. Relate operation temporarily connects 2 tables, but keeps the table physically separate. We can connect 3 or more tables simultaneously by first establishing relates between the tables in pairs. A window based GIS package is particularly useful for working with relates because it allows the viewing of multiple tables. One advantage of the relate is that they are appropriate for all 4 types of relationships. This is important for data query because the relation database is likely to include different types of relationships, but relates tend to slow down data access, especially if the data is reside in a remote database. Relationship class. The object based data model such as the geodatabase can support relationships between objects. When used for attribute data management, a relationship is predefined and stored as relation class in a geodatabase. A relationship class can have the cardinalities of one to one, many to one, one to many and many to many. For the first 3 relationships, records in the origin are directly linked to records in the destination, but For the many-to-many relationship, an intermediate table must first be set up to sort out the association between the records in the origin and in the destination. When present in the DO database, the relationship classes automatically recognized and can be used in a place of a relate operation. Object-oriented model. The object-oriented database model manages data through objects. An object is a collection of data elements and operations that together are considered as a single entity. The object-oriented database is relatively a new model. This approach has the attraction that querying is very natural, as features can be bundled together with attributes at the database administrator's discretion. Today, only a few GIS packages are promoting the use of this attribute data model. However, initial impressions indicate that this approach may hold many operational benefits with respect to geographic data processing. Fulfillment of this promise with a commercial GIS product remains to be seen. The image shows how the object is being represented or how the basic linkage is being shown in the vector data. Summary. Attribute data is found when the data is being recorded in the form of columns and rows, where there are different types of attribute data is present, and we have discussed about different attribute data models, and this enables for fast query and map generation in the GIS technology. For better use of model based on the source of data, the type of model needed to be used. This helps in quick processing, entry of new data, deleting the data, etc. Attribute data model is used for obtaining meaningful information of the map.